3 billion light-years from Earth, something switches on for 90 days, falls silent for 67, then returns. 357 days, the same signal, the same schedule. A precision that no known natural process can reproduce. The researchers who measured it called it quasi-periodic, possibly cyclical. But when they searched for what could keep that kind of clock across intergalactic space, nothing fit. In 2016, a team led by Laura Spittler at the Arecibo Observatory recorded something that should not have existed. The data showed a millisecond flash, intense, sharp, unmistakable, originating from a point far beyond the Milky Way. It was cataloged as FRB121102. At first, the event joined a short list of unexplained cosmic radio bursts, each assumed to be a one-time catastrophe, a collision, an explosion, a star dying in silence. But the evidence would not allow that story to stand. Arecibo's instruments swept the same coordinates again. Instead of silence, they found 10 more bursts, each with the same dispersion measure, the same sky position, the same fingerprint. The source had not destroyed itself. It survived, and it repeated. The discovery appeared in the journal Nature, and with it, the language of astrophysics shifted. No longer was every fast radio burst a singular, terminal event. Here was a source that could act, pause, and act again. What kind of object could unleash such power, then wait, then fire again with no apparent pattern? Cataclysm was ruled out. The old models, mergers, collapses, cosmic accidents fell away. The only certainty was that something persisted, hidden at a distance of billions of light-years, sending signals more than once. The assumption of chaos was dead. Now the search for a pattern had begun, and with it, the uncomfortable possibility that repetition itself might be the message. 3 billion light-years. That is the span between the source of FRB 121102 and the telescopes that first caught its signal. A number so vast it drains meaning from the word distance. Yet, across that gulf, something behaves as if it knows the calendar. The bursts do not arrive at random. They follow a schedule, 90 days of activity, then 67 days of silence, returning with a regularity that can be measured against the ticking of a clock. Very long. Baseline interferometry pinned the origin to a faint, persistent radio source in a dwarf galaxy at redshift Z equals 0.193. Shami Chatterjee, who led the localization, described the odds of a chance alignment as less than 3 in 10,000. The association is not in doubt. What remains in doubt is the mechanism behind the rhythm. Over years of monitoring, analysts plotted each burst arrival, folding the data with the Lomb-Scargill method. The result is a cycle of 157 days, with the active phase lasting nearly 2 months, followed by a silence that is just as strict. The pattern does not drift. It does not blur. Phase jitter remains within a few days, tight enough to rival engineered systems. What kind of process, natural or otherwise, can maintain such discipline over cosmological distances? Why does the window open and close with such precision, as if following an unseen order? The numbers are not ambiguous. The regularity is not an artifact. If chaos rules the universe, why does this source keep time? Peer-reviewed journals do not rush to name what they cannot explain. Instead, the language grows careful, hedged, almost evasive. The first reports on FRB 121102's schedule use the term quasi-periodic. Not periodic, not clockwork. Quasi, almost, but not quite. In the official literature, the phrase possibly cyclical activity appears again and again, each time wrapped in caveats about red noise, windowing, and statistical bias. The cycle is real, the data are clear, but the words remain guarded. Authors of the monthly notices of the Royal Astronomical Society describe the pattern as quasi-periodic modulation, even after accounting for every known source of error. The CHIME-FRB collaboration, presenting a catalog of repeaters, refuses to call it a period outright. Instead, they settle on periodic or quasi-periodic, as if the distinction itself is a defense against what the numbers are saying. No one is willing to write clock-like without an asterisk. No one claims a physical mechanism. Instead, the literature is filled with qualifiers, suggestive, tentative, statistically significant. But is this caution or something closer to discomfort? When the data align so tightly that phase drift is measured in days across years, why does the scientific record step back, choosing words that blur the edges of the discovery? What would it mean if the pattern is not quasi-anything, but simply regular by design? The language of uncertainty hangs in the air, leaving a space for implications that the official narrative will not name. Pulsars, the universe's most precise clocks, spin with periods tracked to 9 decimal places. Yet even the youngest, fastest pulsar falls short. The spin-down deficit is stark. No pulsar can supply the energy for FRB 121102, a radio burst 10 billion times brighter than the sun's annual output, let alone repeat it every 5 months. The numbers simply do not add up. Magnetars, with their immense magnetic fields, unleash chaotic flares, but their violence is random, not rhythmic. No magnetar in our galaxy or beyond has ever shown a 157-day cycle. The literature is unequivocal. Magnetars burst in storms, not on schedule. Regularity is missing, timing is off, and the data is unforgiving. Binary systems, where 2 stars orbit each other, can create periodic signals. But a 157-day orbit should leave clear traces, such as Doppler shifts in arrival times, or changes in dispersion measure as stellar winds ebb and flow. These fingerprints are absent. The 90-day active window, followed by 67 days of silence, fits no known binary pattern. Each standard model breaks under the weight of the evidence. The universe offers no natural engine with this kind of precision. Every conventional explanation fails. A signal leaves a region smaller than a city, somewhere in a galaxy 3 billion light-years from Earth. It travels through a universe that should erase its details. Every textbook on plasma physics insists that as radio waves cross the intergalactic medium, they scatter and smear. Turbulent clouds of electrons stretch and blur anything sharp, especially over such a distance. Yet when the burst from FRB 121102 arrives, its structure is intact. Sub-millisecond spikes, fractions of a thousandth of a second, survive the journey. The scattering timescale, measured at 1.4 gigahertz, is less than half a millisecond. The original shape of the pulse, its edges and fine structure, remain untouched. Physics sets a hard limit. The region that emits this signal cannot be larger than 100 kilometers. Not a star, not a nebula. Something small, something precise. The laws of propagation predict chaos, but the data show discipline. How does a burst, born in violence, keep its coherence across 3 billion light-years? Why do the details refuse to degrade? Is it luck, a perfect line of sight through cosmic emptiness? Or is the preservation itself a message? When randomness is expected, but order persists, what is left to say? The numbers offer no comfort, they only deepen the paradox. There is no comfort in the numbers. In 2020, the Chime collaboration announced a second repeater, FR-B180916, broadcasting from a galaxy 500 million light-years away. Its cycle is not 5 months, but 16 days. 4 days of bursts, 12 days of silence. The pattern is absolute. The window opens, the window closes, and nothing leaks through. 2 sources, separated by billions of light-years, each keeping time with a schedule that does not drift. The search for answers extends beyond the telescope. Freedom of information. ACT requests to NASA, the Department of Defense, and the Air Force yield nothing but silence. No declassified logs, no internal memos, no mention of FRB121102 or its shorter-lived twin. The archives are empty, or the records are withheld. For a century, human civilization has been leaking radio waves into the void, barely 100 years of signals, each one fading into the background. But nowhere in the public record is there evidence that any government has tracked these cosmic clocks or drawn conclusions about their purpose. What kind of process survives 3 billion years of darkness and delivers a schedule that holds, cycle after cycle? How does a 16-day timer or a 157-day calendar persist through the noise of galaxies, plasma, and chaos? These are not the fingerprints of chance. They are the marks of something that knows how to keep time. The universe is not supposed to run on clocks. Yet here, in the data, the clocks are running, and they are not ours. Somewhere beyond 3 billion light-years, the signal resumes. No storm, no spin, no random drift. Not even the universe's oldest clocks match its order. What mechanism dares repeat with such precision, untouched by chaos? Until science names the engineer, doubt remains. Was this meant for us to notice?